Hello guys, this is part of my basic statistics video series. This would help us to address question of probability, especially the binomial probability distribution. So a weighted coin is such that the probability of obtaining a tail is 3 times the probability of obtaining a head. Then we want to determine the probability of obtaining a tail if the coin is tossed 3 times. Then we want to write the sample space, obtain the probability distribution of the random variable x, where x is the number of heads. So the problem wants us to recall the probability of head and tail, right? Using the exhaustive theorem, use the fact that total probability equals to 1, then construct the sample space for the 3 tosses, count the number of heads in each outcome, and then compute the probability of each value of x. And we present this probability distribution in a table. So with that, we can therefore let the probability of obtaining A to be P, and the probability of obtaining T will therefore be equal to 3P, since tail is 3 times likely to occur as a head. So we know that the probability of head plus the probability of tail will sum to 1. Therefore, P plus 3P will be equals to 1. And when we solve, we get our probability of head, which is equal to P to be equals to 1/4, and complementarily probability of obtaining tail will be 3/4. Then the sample space for 3 tosses will be as displayed: S equals to head, 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 tail, and so on. If you count the number of possible outcomes, it will give us 8 possible outcomes. But we can always get that even without drawing the sample space, and that will give us 2 raised to power n, where n is the number of possible outcomes. So the number of heads that can happen or that can occur in these 3 sources of coin is x equals to 0, 1, 2, 3. We can have 0 head, 1 head, 2 head, and 3 head. And when we represent that in a table, we have the table displayed in there, where the head outcome and x is the number of heads in the outcome. So we already obtained the probability of head, the probability of tail, and then when we compute the probabilities of obtaining these random variables, x equals to 0, x equals to 1, we have those values as displayed. You can take time to pause this video to study this slide in order to get my explanation. Then these probabilities will now be represented in a table, which is now what we call probability distribution table. So this is now displayed on the right hand side. So here we see that the probability of obtaining x equals to 0 is 27/64, and so on. When we sum all this probability, it must give us 1. That is to show that the probability is valid. Now, we also observe that x follow a binomial distribution of 3, 1/4. And if we recall the probability distribution formula for binomial distribution, that will give us 3 combination x, 1/4 raised to power x, 3/4 raised to power 3 minus x, for x equals to 0, 1, 2, 3. That will now represent the probability distribution. Therefore, our probability of obtaining the tail is 3/4. The sample space is displayed, and the probability distribution table is also displayed. So you are advised to pause this video to be able to study the slide for a comprehensive understanding of the slides. Thank you for listening. We will therefore afterwards look at the expectation of random variable. Now, for expectation of random variable, we'll look at expectation is the same as also equal to mean, which is sum of xp over times the probability of x, the sum total of x and probability, and the variance is sum of x squared for p of x minus the expectation squared. We can compute this in this the expectation mean is given as the expectation of x, so we multiply all the random variables with their corresponding probability, then we sum all of them. That is shown in the table. Also, we compute expectation of x squared as well, in order to be able to compute our variance, knowing that our variance is expectation of x squared minus expectation of x all squared. That will give us our variance to be 9/16 and our mean to be 3/4. So using binomial, we can as well use binomial formula to obtain these values to explain the expectation and variance. Thank you for listening, and we'll see you in the other video. You can share, like, and subscribe to this channel if this video has been helpful. Bye.